Everyone, welcome back to my channel. Let's do some more Leetcode problems today. I'm Leo. So this is a very famous problem called combination sum. Let's go and read it. We were given an array of distinct integers, candidates, and a target integer target. Return a list of all unique combinations of candidates where the chosen number is summed to target. So you may return the combinations in any order. So this basically suggests we can use any of these numbers to make the target 7. And obviously there are two combinations. One is 2, 2, 3, the other one is 3 itself. So the same number may be chosen from candidates for an unlimited amount of times. Two combinations are unique if the frequency of at least one of the chosen number is different. Okay. So, yeah, and it prompts that the test case is less than 150 combinations for the given input. So that allows us to use the backtrack technique. Okay, let's see how it goes. So first, we'll start out with an empty list, and then we explore the first. Okay, here we explore the first number, which is 2 here. After adding to this list, the difference between the 2 and the target is 5. So we have to go down. And once we go down, okay, we can add another 2. Is that good enough? No, there's still a difference of 3. So we still need to go down. Now we can add 2 here. Okay. Does this 2 suffice? No, we still need to go down. And we add another 2 here. But here, this adds up to 8, which exceeds the target 7. So this cannot be reached from here. Okay, so we have to backtrack. And now, since there are no other ways down, we can always backtrack from here back to the second 2. Then we can try the next number, which is 3. Okay, we got our first answer. Now we can add it to our list and continue the process until it reaches every, it's 6, 7, until it traverses all the recursion tree. Okay, so that should be a basic implementation of this, of backtracking. So let's take a look at the other example. 2, 3, 5, and 8. We can definitely use 4 2s. That's what we explored in the last round. Okay. Okay. So, how do we do this? First, we need a result, and for each part, for each result, we need a container to get all the results. Now we can run the backtracking. What do we need? We need the container and the result, and we need a starting index from the candidates.
In 30 minutes.
And candidates, of course, target. Okay, and then we can return the result. Okay, now we can do the backtracking. Okay. So list of list of integer cur and current index, integer array, candidates, and remains. That's the remaining part. So if remains equals to 0, we can add it to our result. So since this is another function, we need to create a new array list for the container. And else if remains is less than 0, in this case we'll just return. Okay. So next, what should we do? Once we have a fixed number, we're going to go from here to all the rest. Okay. So we're going to use a for loop. current index, I is less than candidates dot length plus, and first we need to add it to our result. Okay, candidates I, and we do the backtrack, and I'll write it later. After that, we'll have to remove the last element to do the backtracking. Okay, so in the backtrack, we still have the result, the current index, which is I, and candidates, and now the remains. Since we added the candidate I there, we need to subtract it from the remains. Okay. Yeah, that should do the work. Let's see. Okay, looks good. So that's a very famous problem. Okay, I think it goes very well. All right, I'll see you in our next video.